Today we're talking about graphing log functions, which is the inverse of an exponential. So we'll look at how we can do it from a table and at a graph. And then we're going to talk about log transformation information. So your A, H, and K, your reference points, and your asymptotes. All right, so before we jump into how to graph these logarithmic functions, there's some information that you need to know about inverses. And we're going to kind of cover those pieces here. So first, let's talk about the inverse of an exponential. The inverse of an exponential is a logarithmic function. So if you'll notice on the bottom right section over here, you'll see the notation f of x. Well, that's our normal notation that we use for a function. So instead of y equals, we write f of x equals. So for an inverse, once we go through the process of changing a function into the inverse, the new notation will be this one on the right, and it's f negative 1 of x. And that's just a notation that tells us, hey, I just went and I found the inverse function, and here it is. So please take note of that. You'll need to do that in the future. So here, I'm going to show you how we're going to use that inverse function notation. It says from an equation. So I'm going to quickly show you how to change this exponential equation into the inverse function. So I know I have currently y equals 2x. You may see it written as f of x equals 2x. It's the same thing. So I'm going to cross off the f of x. I have my y in its place. What you're going to do is you're going to swap the y and the x, and you're going to rewrite it. So now we're going to have x equals 2 to the y power. And then from there, we're going to solve for y. And you've learned to get to the y, to get that exponent by itself, we need to log base both sides. Currently, my base is a 2. So I'm going to log base 2 both sides. This will then cancel the base of 2 with the log 2. And now I'm left with y equals log base 2 of x. And to write so that I know that this is the inverse, I'm going to, let me go back here. I'm going to take the y, and now I'm going to replace it with f negative 1 of x. And now that tells me this is the inverse function I just found. So if you want to make it a little bit nicer, we have f negative 1 of x equals log base 2 of x. Hopefully you can see what I'm talking about. All right, so moving on. All right, so if I'm given in the top left-hand corner of this section from a table, if I'm given a function, if you'll notice here on the far left, this is our exponential function. On the right, I'm going to do the inverse. So I'm going to take these table data, these points or coordinates, and then what you're going to do is you're going to swap the x and y. So from the original. So in my original, y equals 2 to the x power, I'm going to take my x and y values and I'm going to replace them, swap them around, and rewrite them in our new table. So 0, 1 is going to become 1, 0. And I'm going to continue to do this. 1, 2 will become 2, 1. And then I'm just going to continue down until we get to 8, 3. So let's take this table data now and go plug it in on our graph to the right. We're going to start with the 1, 0. Then we've got 2, 1, 4, 2, 8, 3. And you can kind of see how these points are going up and to the right. And before moving on with the points I just posted on there, looking at the graph that exists already, we know this red equation, this red line is our exponential function, our parent function. So it's y equals 2 to the x power. We see that there is a dashed line, a diagonal dashed line. If you recall from Algebra 1, your linear equation, that is your parent function of y equals x. And then if you also recall from our exponentials from this last week's unit, that we also have a horizontal asymptote. And here it's going to be y equals 0. So next, I'm going to go ahead and connect the dots. I'm going to start as I come down. I know because it's a log that it's going to get super close to the y-axis, however, it will not cross. And that's because we now have a vertical asymptote when it comes to logs. So on exponential, we had a horizontal asymptote. Now we have a vertical asymptote. And for the parent function, you can tell that the vertical asymptote would run along this y-axis. So now you can kind of see the reflection. If I were to actually take this graph and I were to fold it on this dashed line here that I'm kind of highlighting and fold it in half on that line, the exponential and the logarithmic functions would actually line up and be on top of each other. So if it's something that's an inverse of each other, they reflect across the y equals x line. All right, so let's take a look real quick about our domain and range for exponential and logarithmic functions. Last week we did exponential. This week we're talking about logs. So on our domain and range for exponential, if you can remember, it would go forever in both directions, to the left and to the right. So you could say that's all real numbers, or you could notate it as negative infinity to positive infinity using interval notation. Now on the range, we were restricted by a horizontal asymptote. So we would go from 0 to positive infinity, or you might say y is greater than 0. Now our logarithmic function domain is now restricted with our vertical asymptote, which means that we're going to have 0 all the way to positive infinity. Or you could say x is greater than 0. And then our range in this instance will be negative infinity to positive infinity, or all real numbers. So as you can see, the domain and range have kind of flip-flop from the exponential to the log. Since they are inverses of each other, this is sort of a natural occurrence. So the range of the logarithmic was all real numbers, whereas before the domain was all real numbers in the exponential functions. Okay, so log transformation information. Y equals a times the log base b of x minus h, and then plus k on the outside of the parentheses. So let's go over each part and what it does, just to kind of recap. Hopefully this will be just review for a lot of you. All right, so let's talk about a. If a is greater than 1, then we know we're going to have a vertical stretch. If a is between 0 and positive 1, then that means you're going to have a vertical compression. And then let's talk about b. What do we know about b? b is your base. If for some reason you don't have a value for b and it's written log of x minus h, then your b is understood to be 10. All right, so H is going to be our horizontal translation, left and right. I like to think about it as a hypocrite, because when you first see it, a negative H you would think goes left, but it doesn't. It's going to move or shift right, and a positive H will shift left. And then we're going to have K. K, I like to call it my special K. It does exactly what it's supposed to do. It's going to actually do a vertical translation up and down. So if it's a positive K, it's moving up. If it's a negative K, it's moving down. All right, so the last piece of information I want to add to this is about your vertical asymptote. To find the vertical asymptote from a function, it's going to be x equals your h value. Okay, so let's talk about reference points. We're going to talk in our first table, this would be for our logs, this would be the reference points that we can start with the parent function. Just remember that the b is going to be the value of your base. Looking at our function or our equation up above, the b will be, we're going to use 5 as our base. Next, I want to go ahead and identify all the different parts. I want to identify what value we're going to use for h, a, and k, and go ahead and write those above the table so we'll have those kind of handy. So for h, we are going to use, it says x plus 5, so we know our h will be a negative 5, so it'll be x minus 5 for our h. Our a value will be negative 2, parentheses, that's when your y, and then plus k. Our k is minus 3. So that's the formula that we're going to use for each one of these points.
So starting with our first point, 1 comma 0, the x value is 1. So I'm going to plug in 1, and then I'm going to bring down my minus 5, which equals negative 4. Then I'm going to take my a value, which we already decided was a negative 2, parentheses, my y value is 0, so I'm plugging that in, and then minus 3 for k. So negative 2 times 0 is 0, minus 3 would be a negative 3. So my new coordinate for my reference point would be negative 4 for x and negative 3 for y. Let's do the next point. Our next one is going to be 5 comma 1, so our x value is 5. So 5 minus 5 equals 0, and then negative 2 parentheses, we're going to plug in what we have for y. What's given is 1, and then minus 3. Negative 2 times 1 is negative 2. Negative 2 minus 3 is negative 5. And again, we're just going to carry that over so you have it written together, 0, negative 5. And then last but not least, let's not forget about our vertical asymptote. This is one more piece of information that we need to make sure we have before we can graph. So just looking at this given equation, remember our asymptote is going to be x equals our h value, and we've already discussed that h is going to be negative 5. So in this case, x equals negative 5. You'll go to negative 5 on the graph. You'll create a vertical line that is dashed, and make sure you notate that. All right, so here we are, the last slide, graphing a log. I just really want to carry over the information I just showed you on the previous slide. We're going to take that same function, we're going to take the reference points and our vertical asymptote, and we're going to throw it on this graph and see how it looks. So if we take the if we take the reference points and go ahead and put those on the graph, we have negative 4, negative 3. And then we've got 0, negative 5. And then the next thing I want to go ahead and do is do our vertical asymptote. That will kind of help you identify where the graph is going to go. So if I go over to x at negative 5, I'm going to put a little line there. That's where our negative 5 is. I'm going to draw my vertical asymptote at this point. So I'm going to draw my dashed lines, arrow on the ends. I'm going to go ahead and identify that this is x equals negative 5. And as you can tell, the points, if you're looking from left to right, the first point is higher than the second point. So that means it's coming from the top, going down and to the right. So I'm going to go ahead and join these. So it's going to get really close to the asymptote. It's going to come down, and you can start seeing it varying to the right. And it'll continue down and up, down and to the right. So there you go. That's visually kind of what a sketch looks like, and that's what you're expected to do. If we want to go ahead and answer a couple of questions about domain and range, domain will go from far left to far right. Obviously, in this particular case, it can't go any further to the left than negative 5. So remember, that's being parentheses, negative 5, comma, and to the right, it will continue on forever to a positive infinity. And then our range would go how far down to how far up. It looks like it's going to go from negative infinity to positive infinity.